Without talking the same language, they understand each other. They're not connected, but one knows how the other is feeling. With the simple click of a mouse, the actions of one can be governed by another. The blurring of the boundary between computer gaming and real life has always been confined to the world of science fiction. In the world of Dr. James Cross, it's now becoming science fact. Modern warfare is a world of satellite data, electronic reconnaissance and tactical intelligence. Fighting units can be deployed anywhere in the world at a moment's notice. Commanders must control vast numbers of troops, giving them orders and up-to-the-minute intelligence from thousands of miles away. But getting information rapidly from command centre to soldiers in battle is challenging the designers of military hardware throughout the world. Dr. James Cross is combining the logic of computers with the intuition of humans, designing a system that puts the hardware now used in helicopters and tanks into the uniforms of frontline troops, turning each soldier into a fighting machine linked to a global network.
We can attach sensors to him, we can see what his heart rate is, we can tell if he's stressed, we can tell if he's dehydrated, we can tell if he's injured, if he's been shot, if he needs medical assistance. Using certain sensors we can even tell exactly what kind of medical assistance he can have. And of course we know exactly where he is now in the field, so if we need to send someone out to give him any assistance, we know exactly where to go.
Clearing landmines is one of the most dangerous tasks carried out by today's soldiers. In this simulation, electronically gathered intelligence is used to guide the soldier through a minefield. But the information doesn't just go one way. When the soldier detects a mine, the exact location is uploaded on the network and passed back to base. This intelligence can then be shared with others.
We can detect things like incoming weapons fire, we can tell what direction it's come from, which can all be plotted on this map. Even if the soldier's been killed in the field, we can still tell where incoming weapons fire is coming from. We can still actually gather information from him, environmental information.
James is the mastermind behind the system that makes all this possible.
This is the wearable computer system. In here we have a full computer, including the hard disk, and to display it we have a head-mounted display, which includes a monitor and some optics so that you can see what's going on in the actual display. And this fits on the helmet. And we just connect this up to the wearable computer. We can connect all sorts of different sensors to the wearable computer. In this case it's connected to a metal detector for detecting mines or other unexploded ordnance on the field. We have a GPS system on here to get location sensing, so we can see exactly where he's been, where he's going, and get the position of targets and things that he's seen and found on the field. Okay, this is an electronic bird table. What it does is gives us a visual representation of what's going on in the field, the mobile units out in the field, and what they can see. It doesn't matter how many units there are, they're all represented on here, and what you can do is you can interact with those units, and the commands that you send from here get sent to the actual guys out in the field. So for example, if I want to send this guy south, I'll point to him and I'll say go south, and what will happen is he should receive the command and start going south straight away, and you can see him going between two mines there. Okay, so in this scenario I just want him to avoid those mines, so I want to send him down here and out here. This server can be located anywhere in the world as long as it's connected, and we are actually going straight over the internet with this particular demonstration. So yeah, the commanders don't even need to be in the same country, they can be anywhere, and you could have units all over the world.
And in a climate of global cooperation, language will no longer be a barrier.
The commander may be French speaking or English speaking, and the people out in the field, the troops, may speak a different language. Because we're using a data link and not actually voice commands anymore, he can receive the command in his own language, and even send his command or his interface can be actually in any language you want. And essentially it translates to the same thing over the network. So it's language independent. You can coordinate forces from different countries. I would say that wearable computer is almost like a logical progression. It's, you know, gradually the computers have got smaller and smaller, lots more mobile now, and because they're so mobile, all that computing power on your desk can now be taken out into the field.
It's not difficult to find the source of James's fascination for engineering.
When he was a boy, he was always playing with batteries and torch bulbs. In fact, we called him Torchy at one stage. He was that keen. My wife used to go after New Year's Day and buy any reject toys or broken toys just for James to take apart, strip down, find all the parts and then reassemble it.
But it's no longer toys James is fixing. It's a serious business maintaining and flying your father's light aircraft.
I did work experience at Rolls-Royce Testing and Measurement, and I found it fantastic and amazing that they could put devices inside engines that's actually spinning around at the full power of this engine, and it's recording stresses on the engine and exhaust gas temperatures and stuff like that. And I thought, I really want to do this. I want to do this kind of design. It's great. You never have to do a hard day's work because you just play. You're just doing. My hobby's turned into my job. I'm nuts about engineering. Always have been.
James is very excitable and exciting when it comes to looking at engineering projects. He will get enthusiastic about something and attack it as a problem, research it and research it and research it, build something, continually refine something. And one of the problems of managing somebody like that, I suppose, is to get to a point where you can say, stop refining it, we can use that now, because he's continually trying to make things perfect.
James's research into wearable technology is driven by its military uses, but having this much computing power at your fingertips can give the user the edge in many situations.
Some of my earlier work was involved with forensic archaeology. We were working with mass graves, and what the idea was, wanted to be able to locate where things were. Much like any other type of archaeology, needed to be able to record vast amounts of information of all different types, ground penetrating radar, all sorts of different types of data had to be overlaid onto a specific area.
In archaeology, the features and artefacts of each site must be pinpointed and plotted before they're destroyed by the next stage of the excavation. James has made a simple device that lets archaeologists plot a 3D map of each trench, simply by tracing a finger over it. The cursor is placed at every key point on the site. The XYZ data for each point is recorded onto the wearable computer with a simple click of a button.
This is basically working a lot like a microphone. And what it's doing is it's listening out for a signal coming from each of the transmitters in turn that are dotted around the room. And using a radio receiver, it's able to work out the difference in time between the radio signal and the sound signal, and it uses that in order to calculate how far away it is from each of them. And then working that out, it can then work out its actual position in 3 dimensions. The system is accurate to around about 1 centimetre, so if I move the receiver away from me, towards me, up, down, left or right, it will then reflect those in the readings on the system.
Although it's an early prototype, the civilian uses for this technology are already apparent. The system can be quickly deployed and allow scene-of-crime officers to accurately record all the evidence at a crime scene without the time-consuming use of tape measures or rules.
Well, with crime scene investigation, you need to, it's very much like archaeological work. You're basically interpreting lots of things around the room. So if there's blood spatter up the walls, the pattern of the spatter may be able to give clues as to what kind of murder weapons used, that kind of thing. You might need to know exactly where the body fell to be able to determine if it was foul plays involved, for example. So positioning is as important indoors as it is outdoors for other applications. And using the local positioning system, you'll be able to get all those measurements very quickly. And of course, because the system's wearable, you can then send that information to somebody else. You can say, can you measure something for me? And then we'll get that information back straight away.
James works right across the board, and our intention is to produce fully functioning prototypes, because without the prototypes we can't test the concepts on people to use those different sorts of technologies. So in order to make something work, James needs to design the casing, he needs to put the hardware into the casing, he needs to write the software to make the hardware work, and he needs to fit it onto the person. So it's a total engineering that he's doing.
Our workshop has computer-controlled milling machines, which allows us to machine things exactly how I actually want them. So with powerful computer software and CAD packages, I'm able to design things and get them looking how I actually want them now, without actually going anywhere near any hardware. Sometimes I'll put it on the table and I'll build a mock-up out of cardboard or something just to make sure that it's all going to be right. Like the wearable at the moment, the aesthetics are quite important of that. We don't want sharp corners, because these are a problem. You know, you go out in the field, you've got sharp corners, you end up getting injured on them. So it needed to be rounded, and the design's quite important. Wanted to make it look, you know, aesthetically attractive as well.
Not only does the system look great, the potential benefits it offers are limitless.
Wearable computers can be used, to help firemen in burning buildings. It can, with sensors, on-body sensors, we can sense things like poisonous gases. Using infrared cameras, things like that, you can see through the smoke. It almost gives you superhuman abilities. You've got the ability to recall information from anywhere on the internet, everywhere that you go, all the time. And you can send that data backwards and forwards. With the police, it was only the vehicles originally that had sort of an online database of what's going on backwards and forwards, particularly in America. And over here, there's more and more electronics being involved in crime fighting. And like we use helicopters. I think everybody's seen the helicopters flying overhead, and it's looking down at the ground with infrared cameras. And now all that information can actually be brought down to people on the ground so they can see what's going on. And it gives you a better awareness of what's going on. And in the future, everyone will be able to see anything from any of these points of view. Wherever you've got a person, you'll be able to see what they're doing or what they're seeing at all times.
James's key skill is problem solving. Wearable computing is revolutionary, but like all new technology, it has its drawbacks.
Obviously you can't walk around with a big monitor strapped to your head, and you can't really cope with a very high resolution display with lots of things going up it like you would on, like, for example, like the Terminator. It's got all these, it's telling you, someone's breathing smoke on him, it's giving him a chemical analysis for the smoke. Well, we can do that, but, if you're in a situation where someone's shooting at you, you really don't want to be sitting there reading lots of information and scratching your head, wondering what it means.
But like many of the problems James encounters, he's already perfecting a solution.
To make the interface simpler to use, it's like what we like to call a glanceable interface. So you can tell what mode it's in without actually specifically reading it. If you learn just a few colours, you can tell immediately what mode the system's in without having to actually look at it directly. So for example, if I choose map, the background to the whole pie menu becomes green, so you know that you're in the map mode. If I chose radio, it's white. Target selection, the whole lot goes orange. So straight away in the corner of your eye you can see that it's a colour, and then you know what mode it's in without having to look directly at the colour.
Target selected. Target displayed.
The challenge of making huge computing and communication power available to us as we move around takes James into many different areas of science and engineering, from software to psychology and even clothing design. His real skill is solving problems and getting hold of whatever expertise he needs to do it.